Hello, this is John from caveofprogramming.com, and this is a tutorial on natural order in Java. And we're going to look at natural order in the context of sorting arrays and in tree sets and tree maps. And we're also going to look at how you can define the natural order for your own classes. So I'm going to start here by creating a list, and this is going to be a list holding strings, and I'll call this list and set that equal to a new array list of string objects. And I'm going to add a bunch of strings to this list and then sort them in their natural order, which of course for strings is alphabetical order, and for numbers it will be numerical order. So let's also here have I'll also have a set. I'll make this set also store the same strings, and I'll call it set, and I'll set that equal to a new tree set. And tree sets store their elements in sorted in natural order. And I'm not going to look specifically at tree maps here, but tree maps work the same as tree sets. That is, they store their keys in natural order, automatically sorted. So in fact here, if I wanted to emphasize that this was a sorted set, I could use the sorted set interface here rather than the set interface. It doesn't make too much difference. That's just kind of a reminder that it is a sorted set and not an unsorted set, like hash set basically. So now, because I want to add the same elements to both of these collections, I'm going to define a method here. Let's make it private static void, and this is going to be called add elements, and this is going to add a bunch of strings to whatever collection I pass in. Now if you want to pass a list or a set to a method and you don't even know if it's going to be a list or a set, in fact they both implement the collection interface, which is a super interface of list and set. It's the parent interface, and you can't do much with the collection interface other than add and remove elements or iterate through them, but it's perfect for what I need here because I can use the collection interface with the string type here to add elements to my two collections and to iterate through them as well, which saves me typing everything twice. So I'll have a parameter of the type collection parameterized on strings here, and I'll just call that col, and let's add the import there. And I'm going to use col just to add some items to whatever collection I pass in, and I'm going to add here let's have the names of some people. So I'll have a person called Joe, and I'm going to copy that, and I'll have in total 5 elements here. I'll have Joe, Sue, let's have Juliet, Claire and Mike. And now I'm also going to define a method for displaying my collection. So let's just copy that because it's going to look pretty similar. I'm going to call this show elements, and this is going to iterate over the collection and display it. So for string element in col, which is the parameter there, I'm just going to call sysout on that element like this. And now up here in my main method I can use these two methods. I can say add elements to the list and add elements to the set that I've defined, and then we can use show elements for the list, and then let's just do a sysout here to have a blank line, and then I'll do show elements for the set. Now what this looks like is, okay, so tree set is going to be sorted automatically, and I can sort the list as well by saying collections. We saw this in the last tutorial, collections dot sort, and just pass in the list. and as long as the elements in my list have their natural order defined, which strings do, then this will work and it will sort them in natural order. So if I run this now, I've got here first my list sorted in alphabetical order, and then my set sorted in alphabetical order as well. Claire, Joe, Juliet, Mike, Sue. Claire, Joe, Juliet, Mike, Sue. Now the question is, what do you do if you've got your own object that you want to put in there? How do you define a natural order for your own type? And I'm going to create here a class called person, and to keep things really simple, I'm just going to give person a private string name, just the one field there, and let's give person a constructor that accepts the string name and just sets this dot name to the name that's passed in, like that. I'm not going to bother with any get or set methods, but I'm going to have a toString method, so public string toString, and I'm just going to return name from toString. Now let's make some changes to put person objects in these collections instead of strings. So I'll type person there, and person needs to go here, here and here, and also here. So the collection is also parameterized on the type of thing that's in it. And when I do the add, I need to say new person and pass the name to the constructor. Let's copy that, because then I can paste it in these places down here, and I need to put the closing brackets in as well, like this. And person also needs to go here when I'm printing it out, so the elements of course are person elements, and that's almost it, except that because the person object does not yet have a natural order, I can't call collections.sort on it, and also the tree set is going to give me a headache, because you can't add elements to a tree set unless they have a natural order defined. So if I run this, I get a trace back actually from the tree set here where I try to add an element. So we're going to fix that now, and the way to fix it is you need to define a natural order for the person, and you do that by saying implements comparable, and you type comparable on the thing that you want to compare your class to, which is going to be in this case other objects of the same class, like this. Now if I go to add unimplemented methods, we get this compare_to method here, and this compare_to method works exactly like the I think it's the compare method that we saw in the comparator interface in the last tutorial, and that is you're going to get, basically you've got an object here that you can access with this when you create objects from this class, and another object of the same type is going to be passed in here. I'll call it person, and you want to return -1 if the object you're in here is less than this person, return +1 if the object you're in here is greater than this person, and return 0 if they are equal. But before I do that, I'm going to add something else, because to actually add your elements to a set, your objects to a set, as we saw a couple of tutorials ago, you need to define the hash code and equals methods, and I can do that just by right clicking here and going to source, generate hash code and equals, and I've just got one field here, name, to compare them on. And these methods are, well, hash code is going to return a ID that's different if the names are different in this case, and equals is going to return true only if the names are equal in this case. So now I can add my items to sets, but I still can't add it to tree set until I fix this compare_to, and what I'm going to do to start with is I'm going to make these person objects sort in alphabetical order of their names. And the way to do that is to use the compare_to method that's already defined for strings, because strings already have a natural order, and the same thing works for integer objects and double objects and so on. So here I'm just going to say return this.name. This is actually superfluous, so I'll just type this, compare_to, and person.name. So although the name field is private here, I can still access the names of other person objects here, because we are within the person class. So it's not private, doesn't restrict its use from within the class, even though it's from another object. So if I do that now and I run that, I'm going to get here, let's make this a bit bigger. I've got my list here is sorted in natural order, which is now alphabetical order, and so is the tree set, and so would be the keys in a tree map if you were using this person as the keys in the tree map. We can sort in reverse alphabetical order just by putting a negative sign there, because then the negative one, which means that this person is less than this person, becomes a +1, and the +1, which means that this person is greater than this person, becomes a -1. So you're switching around the order, and the 0, meaning they're equal, works just the same. So if I run that now, we've got sorting in reverse alphabetical order. Now supposing I want to do something a bit stranger, and we're going to encounter a little gotcha here, but supposing this would work fine if you want to sort on using some numerical field or some string field, but supposing you want to sort on something a bit stranger, like for example the length of a string. So let's start by getting the length of the name of this person, the one of the object that we're actually in. So I'll say int len1 equals name.length, name.length, like that, and int len2 equals person.name.length. So this is now the length of the name of the person that's passed in to compare with this person. Now I'm going to say if len1 is greater than len2, then in that case, if the length of this name is greater than the length of this other person's name, then I consider this object to be greater. In other words, by greater I mean it sorts later on in the sorting order, just like greater numbers sort later in the order 1, 2, 3, 4, 5. So in that case I return 1 to say that this is greater than this other, the value associated with this other person here. And if else if len1 is less than len2, then I return -1 to say that this person is less than and sorts earlier than this other person. And if they are equal, I'm going to return 0. So if they're not greater than, and if one is not greater than the other and it's not less than the other, then they have to be equal, so I'll return 0. And if I look at that, you can see there's a little problem here, because it's worked fine for the array list. It's sorted the array in order of the length of the names, and for the tree set it's sorted them in order of the length of the names, but we seem to be missing a name. And why is that? Well, if you look closely, the name that's missing here is Sue, and Sue happens to have the same length as Joe. And if you look at the documentation for I think it's for the comparable documentation, it actually says that if there's a conflict between the notion of equality in a tree set the notion of equality returned by the equals method versus the notion of equality returned by the compare-to method. If there's a conflict between those two, then the behaviour of items in a tree set, or for that matter a tree map, are quote strange. And what it boils down to is you've got to make sure that if your comparator is saying that two objects are equal because by returning 0, then that must match what your equals method says. That must be returning true at the same time. And if they're not equal, then equals must be returning false at the same time. You mustn't have a conflict between these two if you want to use comparable to add your objects into a tree set or a tree map or some kind of other data structure that sorts things in natural order and also contains only unique values, because that's the problem here. What's actually happening in this particular case, although the results could be unpredictable potentially, is that TreeSet is saying, okay, this is saying that Joe and Sue are equal because it returns 0 for both, saying that they're equal. And because a tree set, like the keys in a tree map, only contains unique elements, it's saying, okay, those two elements, if they're equal, they're the same element, therefore only put one of them, only keep one of them in the set, in the tree set. And the way to deal with that is you need to just put a bit more code in here to make sure that this notion of equality always agrees with that returned by the equals method. And what I can do is I just need to think about the case where we've got two strings that are actually different strings and yet they have the same length. And what I can do is I can just say I can do here return name.compare2 person.name, because this is only going to return 0 if the two names are in fact actually equal, and if they are not equal, so it's only going to execute this code if they have equal lengths. And if they have equal lengths, we need to do some more comparing to try to figure out what order they should be in. And I'm kind of deciding here, okay, if they've got equal lengths, just put them in alphabetical order. And to put them in alphabetical order, I can just use the compare-to method of the string to do that. And now if I run this, it works as we kind of hoped it would work, and the set has all the elements in there, and it's sorting. See, Joe and Sue, they have the same length, but it's now sorting them in alphabetical order, just within this little group where they have the same length. So that's it for this tutorial. I think that's basically the whole lot. Of course, another possibility here is that I could have left this as it was, and I could have just changed my equals method here so that it only returns true in the same circumstance where this returns 0. And then I would have had well-defined behavior, but it would have meant that I couldn't have two strings of the same length in my set, which could be what I want, but probably it isn't. Okay, so that's it for this tutorial, and in the next tutorial in this series we're going to look at queues. So join me again then, and until next time, happy coding.